Hello, and welcome to another IB Math Speedrun with me, Vince. So today we're going to be going through chapter 4.3 of the textbook, which covers different rules we can use to help us with differentiation. So let's jump right in. So earlier we learned that we can derive a function from first principles by using the equation lim as h tends to 0 of f of x plus h minus f of x over h. But this, takes a long time. If you watched the previous video, you would have seen how long this takes. And so there are some simple rules that we can use to speed up our differentiation of common functions. So let's go through them. First of all, if f of x is equal to a constant, then its derivative is simply equal to 0. Remember that the derivative measures the rate of change. If the value is constant throughout the entire function, that means the rate of change will be 0. And if f of x is equal to a linear equation, mx plus c, then f dash x will be equal to m. Remember, the derivative or the derivative of the equation will be equal to the rate of change, and in the linear function, the rate of change is simply the gradient. So yeah, those are some simple rules. Now we need to get a bit more complex so we can differentiate more functions. So first of all, it's something called the sum rule. So if we have, say a function is equal to two different functions added together, so you say u of x plus v of x, well, the derivative, f prime, will be equal to the sum of the derivatives as well. So that's a neat little trick we can use when solving just functions that are composed of other functions added together. Another thing is, if we have a constant multiplied to a function, so if we're getting the derivative of this whole function, where we have a constant multiplied to the function, well, this is simply equal to the constant times the derivative of the function, as long as the derivative exists, of course. So this will be useful when we have, when we have constants being multiplied to functions, I guess, or yeah. And okay, the final one and probably the most important rule. Oh, I don't know what that is. The most important rule that we need to know for this lesson is that if we have a function which is equal to x to the n, then its derivative will be equal to n times x to the n minus 1. This is probably the most important rule that you need to know, and it's called the power rule. It will help you simplify your calculus life a lot. So remember that if you have a function that's x to the power of n, then its derivative will be, we bring down the power and then we subtract the power, we subtract 1 from the power. Okay, so let's jump right into some questions, and I'll be doing the even ones today because I'm feeling like a challenge. So we need to use the power rule and find dy over dx. Remember, dy over dx is the derivative. And okay, just one thing about notation: if a function is expressed in terms of like y is equal to x something, then we express the derivative as dy over dx. If, however, it's expressed as a function, say f of x is equal to something, then we express the derivative as f prime x. So that's one thing to note. So the first equation we're doing is y is equal to 3x to the 5th minus 4x squared plus 2x minus 1. So using the sum rule, we know that the derivative of this, dy over dx, will be equal to the sum of the derivatives of each individual function. So we can take all of these as individual functions and get their derivatives. Now, using the power rule, using I don't know what the name is, but remember that the derivative of a function, if there's a constant before it, well, we keep the constant and we multiply it to the derivative of whatever value this has to get the real derivative. So, well, what's the derivative of x to the 5? Using the power rule, remember we bring the power down, and then we multiply it by 1 less than the power. So we get 3 times 5x to the 4. So we get 15x to the 4. Now, for the next one, we have minus 4 times, well, we need to get the derivative of x squared. And remember, we bring the power down, so we get 2 times x to the 1, which is simply 2x. So we have minus 8x. Finally, we have this 2x, so this is 2 times, well, what's the derivative of x? The derivative of x is simply, well, 1 times x to the 0, which is simply 1. So the derivative of 2x is simply equal to 2. Now, the derivative of a constant is always equal to 0, so our final derivative of this entire function is 15x4 minus 8x squared plus 2. Okay, on to the next one. So for our next function, we have y, we can draw y is equal to 5x cubed, zoom in, 5x to the 5 minus 4x cubed plus x minus 1 over 4x cubed uh, 4x cubed minus 1 over 5x to the 5th. Okay, so we have, well, dy over dx is equal to, what's the derivative of this? Well, the coefficient is going to be the power times this number, so that's 25x, and then we subtract 1 from the power, so 4. And then here, power times coefficient is the new coefficient, so minus 12x squared, subtract 1 from the power, plus 1. Derivative of x is always equal to 1. And for these last two, well, what are we going to do? In this case, we need to express this in terms, as 4x to the negative 3. Well, actually, this would be 1/4 x to the negative 3. And this would be 1/5 x to the negative 5. So we need to be aware of this. So we can still use the power rule for negative powers. It actually works for all real numbers. So we have negative 3 times negative 1/4, so that's plus 3 over 4 x, and then we subtract 1 from the power. So in this case, it's not x squared, it's x to the negative 4. And then over here, we have negative 5 times negative 1/5, so that becomes 1 x to the negative 6, since negative 5 minus 1 is negative 6. So that should be our answer. Yeah. So next we have the equation y is equal to the square root of x. Well, what will this be? Well, we need to express this in terms as, as x to the 1/2. Remember that x to the 1/2 is equivalent to the square root of x, because this is equivalent to, how do I explain? If we write y is equal to x to the 1/2, then y squared must be equal to x. So therefore, it's equivalent to y is equal to the square root of x. So yeah, in case you didn't know that, well, we can convert it into a fraction, and then we can simply use the power rule. So dy over dx is equal to, bring the power down, so 1/2 x, and then subtract 1 from the power. 1/2 minus 1 is equal to negative 1/2. So this new derivative will be equal to 1/2 x to the negative 1/2. Okay, next we have y is equal to the square root, the 5th root of x squared. Okay, and so just like the previous one, we can actually express this as y is equal to the x to the power of 2 over 5. So yeah, just a handy hint, if you're getting the root of a number to a certain power, you can also express it as x to the 1 over n, or n is the number over here. So getting the derivative of this, dy over dx, will be equal to, bring the power down, 2 over 5, x times 2 over 5 minus 1, which is negative 3/5. So this will be equal to 2/5 times x to the negative 3/5. Oops. Okay. And then on to the final question, we have y is equal to 1 plus square root x times 3 minus cube root of x. So let's expand this equation. So we will get 1 times 3 is 3, plus 3 square root x minus the cube root of x. Well, what's the square root of x times the negative cube root of x? Well, that will be equal to x to the 1/2 times x to the 1/3. So if we're multiplying two powers, remember we add the exponents. So 1/2 plus 1/3 is actually equal to 5 over 6. So this is minus x to the 5 over 6. So yeah, let's convert these other roots into powers. So 3x to the 1/2 minus x to the 1/3. And now we can find the result of the derivative. So dy over dx is equal to, well, if it's first is a constant, remember the derivative of a constant is 0, so we ignore that. Next one, 1/2 times 3 is 3 over 2. X to the 1/2 minus 1 is negative 1/2. Minus x to the 1/3. So this will be minus 1/3 x to the, well, what's 1/3 minus 1? It's negative 2/3. Finally, we have minus x to the 5/6, so this will be minus 5/6. X to the, what's 5/6 minus 1 is negative 1/6. So the final equation should look like this. Yeah. Okay, next, on to the next one. We need to find the equation of the normal to the curve. So we need to find the normal to the curve of y equals x minus 3 over x at x is equal to negative 1. So to find the normal to the curve, well, we can split this into two separate fractions. So this will be x over x, or 1, minus 3 over x, which is, of course, 3x to the negative 1. And so now we can get the derivative of this function, which is, well, constant, and then here we have negative 1 times negative 3, so we have 3 times x to the negative 1 minus 1 is negative 2. So the derivative of the function is 3x to the negative 2. And so to get the gradient of the tangent, we plug in x equals negative 1. So the tangent will be 3 times negative 1 squared to the negative 2, which will be equal to 3. So since the gradient of the tangent is 3, the gradient of the normal must be negative 1/3. So we know that the equation of the normal must be equal to y is equal to negative 1/3 x plus c. And so we need to find the coordinates of this function at x equals negative 1. So when x equals negative 1, y is equal to negative 1 minus 3 over negative 1. So this is simply equal to 4. So the coordinates negative 1, 4 must also be on the normal. In this case, we have 4 is equal to negative 1/3 times negative 1 plus c, which is equal to 1/3 plus c. So we have c must be equal to 11 over 3. So we have y is equal to negative 1/3 x plus 11 over 3 as the final answer. Yeah, that's correct. Okay, on to the next question. We have the question, find the equation of the tangents of the function f of x is equal to x cubed minus 5x squared plus 5x minus 4, and we need to find the equations of all tangents whose gradients are 2. So first let's derive this function. Get the derivative, f prime will be equal to, bring the power down, and then what's 3 minus 1, 2, minus 5x squared, bring the power down, minus 10x, 2 minus 1 is 1, plus 5x. So this is simply plus 5. So we need to find all cases where the gradient is 2, so we can simply substitute 2 into here and see what x pops out. So we have 2 is equal to 3x squared minus 10x plus 5. And so we have 3x squared minus 10x plus 3 is equal to 0, which of course factorizes into 3x plus 1 times x minus 3. Oh, 3x minus 1 times x minus 3. So we know our values of x will be when x is equal to 1/3 and when x is equal to 3. So we need to find the equations of both tangents at these points. We know the gradient is 2 for both of them. So we know y is equal to 2x plus c for both. And so let's find the coordinates on the curve at these points, 1/3 and 3. So at 1/3, this will be equal to 1/3 cubed minus 5 times 1/3 squared plus 5 times 1/3 minus 4. So this is equal to 1 over 27 minus 5 over 9 plus 5 over 3 minus 4. So if we convert this all over 27, this would be equal to 1 minus 15 plus 45 minus 4 times 27 is 108, all over 27. And so we should get that this is equal to 1 minus 15 plus 45 minus 108. It's equal to negative 77 over 27. So in this case, the coordinates must be negative 77 over 27 is equal to 2 times 1/3 plus c. So we have this is equal to 2/3 plus c. So c must be equal to negative 77 over 27 minus a further 2 times 9 minus 18. So this is equal to negative 95 over 27. Yeah. Quite a yucky equation, actually. I might, I want to check if I've got this right, but I think this is correct. So we have y is equal to 2x minus 95 over 27. Should be your answer here. And the other case where we have x equals 3, sometimes a much nicer number. So this is equal to 3 cubed minus 5 times 3 squared plus 5 times 3 minus 4. It's equal to 27 minus 45 plus 15 minus 4, which is equal to 27 minus 45 plus 15 minus 4 is equal to negative 7. Okay. If that's all equal to -7, then we have -7 is equal to 2 times 3 plus c. So c must be equal to -13. So our two equations are y equals 2x minus 95 over 27, and y is equal to 2x minus 17. These should be the two equations that you've got. Oh, sorry, 17? 13. Sorry, 13. Yeah. Okay. On to the next question. I think it's the final. No, yeah, it's the final question. So we need to find the equations of the tangents x cubed plus x squared plus x minus 1. We need to find the equation of the tangents to this line that are normal. Just write f of x, and they need to be normal to the line x plus 2y plus 5 is equal to 0. And if they're normal to this line, well, let's rearrange this. We get y is equal to negative 1/2 x minus 5 over 2. If they're normal to this line, negative 1/2 x, that means the gradient must be 2 again. So let's get the derivative of this. And this would be f prime is equal to 3x squared plus 2x plus 1. And so if the gradients are equal to 2, we need to set this equal to 2. So we have 2 is equal to 3x squared plus 2x plus 1. So we have 3x squared plus 2x plus minus 1 is equal to 0. And so solving for this, we get 3x minus 1 times x plus 1 is equal to 0. So we have x is equal to negative 1/3, to 1/3, or x is equal to negative 1. Or x is equal to negative 1. So let's find the equations of these two lines, knowing the gradient is 2. So we already have y is equal to 2x plus c. Y is equal to 2x plus c. And so let's substitute 1/3 into the original equation first. So this pops out 1 over 27 plus 1 over 9 plus 1/3 minus 1. So this will be equal to 1 plus 3 plus 9 minus 27 is equal to negative 14 over 27. So we know that negative 14 over 27 is equal to 2 times 1/3 minus c, plus c. So c must be equal to negative 14 minus 18, negative 32 over 27, I believe. And so our final equation is y is equal to 2x minus 32 over 27. Okay, now onto this one, x equals negative 1. Well, what will this equation be? When x equals negative 1, this is equal to negative 1 plus 1 minus 1 plus 1. Oh, minus 1. Minus 1. In other words, is equal to negative 2. So we find the value negative 2 is equal to 2 times negative 1 plus c. We simply have c equals 0. So our two equations are y equals 2x minus 32 over 27, and y is equal to, this is just y is equal to x. 2x, sorry. So yeah, those should be our two equations, and that's all. So that's all for the speedrun. I hope you enjoyed it, and I hope to see you in the next one.